To be the first to enter the cosmos, to engage, single-handed, in an unprecedented duel with nature. Could one dream of anything more?
The Interplanetary Podcast. The exploration of space for the benefit of all mankind. Your hosts here in London, Matthew Russell and Jamie Franklin.
Matt, who was that lovely gentleman?
Well, it kind of gives it away in the first sentence, doesn't it? To be the first to enter the cosmos.
Yeah, but maybe someone was just talking about their first psychedelic mushroom experience.
Yeah, true.
Which surely was ages ago.
Was it?
Isn't there some theory, Matt, that when monkeys started to eat magic mushrooms, that's when we really soared?
Oh my God.
That's a whole other podcast.
That's definitely ranking in like one of those things where you see it on like BuzzFeed and you go, oh, come on.
Yeah, that's Alex Jones territory.
Yeah, big time. Anyway, it's the first person in space, Yuri Gagarin.
Just one of the men, isn't he?
Unbelievable.
Tick.
First man in space.
Imagine going up and being him, what he was going through.
I bet he was terrified. No matter how cool he was, he must have been terrified. Yeah. It's ridiculous.
Incredible stuff. Matt, what have we got today?
Well, August the 17th, 1970, Venera 7,
yes,
which launched on Molniya, which is very similar to a Soyuz, actually went all the way to Venus and became the first spacecraft to ever transmit data from another planet, from the surface of another planet, no less.
That's big news.
Yeah, so it was transmitting for 53 minutes as it fell through the atmosphere. 20 minutes of that was on the surface.
What stats did it throw back?
Stats, temperature. Have a guess at what the temperature was.
Now, I know this because we did an episode where we said it was even hotter than having the ability to melt was it an iron or a steel bar?
Yeah.
On the surface?
Yeah.
Which
or
I
bar,
believe was
perhaps.
something like 300 and something. That was like 300 and something. So I'm going to say 400 degrees Celsius.
Ooh, 475 degrees Celsius.
Oh, I was in the right ballpark.
Yeah. And we know because of the way that it sort of halted that it landed on a hard surface, so there's not much dust on the surface. So they learnt loads from that.
Incredible scenes.
Absolutely amazing. And 12 years before that, on the same day, so 12 years before, was Pioneer 0, which was America's first attempt at a lunar orbit. So it would have been
yes,
one of the very first launches beyond Earth's orbit on a Thor-able rocket. But unfortunately, it failed.
I mean, you would have thought with the word Thor in the title, they would just smash it.
So it turned out to be not very able.
Oh, well.
And 150 years ago on Saturday, French astronomer Pierre Janssen discovered helium.
Okay, so do we know the circumstance in which he discovered it?
I don't actually know much about it. I mean, we could look it up.
Just by accident? Well, lots of things happen like that. Penicillin, Matthew. A bit of bread was left out and it went mouldy.
Yeah. Let's move on from history and have a bit more history. Who is our space legend of the week?
Well, Matt, this week we have the mighty, the powerful Umberto Guidoni. Born 18th of August, Matt, 1954 in Rome. He was an Italian astrophysicist, science writer, and former ESA astronaut. Happy birthday, Umberto.
Yeah, do you know what? He was the first European to visit the International Space Station.
He was, which is incredible. He is also a veteran of 2 NASA Space Shuttle missions, which was STS-75 and STS-100.
Yeah, so it was STS-100. He became the first European. So that's the one that took up the Raffaello multi-purpose logistics module and also took up the space station remote manipulator system, or as some people call it, Canadarm.
He was also a doctorate in astrophysics from the University of Roma La Sapienza. In 1978.
Yeah, so he's Dr. Umberto Guidoni.
He is.
Yeah. He's done loads of things. So he was at STEC for ages as part of the support for the payloads for Columbus. He's done radio programs like from Sputnik to the shuttle, and he's also written loads of books.
It's pretty good, isn't he?
And he's been a member of the European Parliament. He's been an MEP from 2004 to 2009.
Really?
Yeah, as part of the Italian Communists.
Wow.
Well, yeah.
Okay.
So he's had a very varied career. I've never heard of Umberto Guidoni before.
Me neither. What a colourful life.
Yeah, and I'm assuming that in Italy he's an absolute legend. So our Italian listeners will be going, "Oh, come on!" It's like not hearing of Tim Peake or Mike Fole or one of those people.
In fact, could one of our Italian listeners please write in and tell us when you say that word, when you say his name in Italy, what do people say? How's he regarded? Write in, let us know, please.
That'd be awesome. So what's our space word of the week, Jamie? Space word of the week.
Matt, I'm excited this week because it's only Delta V.
Delta bloomin' V.
Pronounced Delta V. None of this Delta 5, please.
Well, it could be pronounced Delta 5 if you were talking about a rocket
but Matt,
called Delta 5.
You're just going to confuse people because that's the rocket, right? So this is the difference or change in velocity. Used in spacecraft flight dynamics, it's a measure of the impulse that is needed to perform a maneuver, such as a launch from or landing on a planet or moon, or in-space orbital maneuver.
Yeah, so it's slightly more complicated, isn't it, than a difference of change in velocity, because it's a scalar, meaning it's got magnitude and direction, and the unit's obviously speed. So it's used in the context of, things, what it has to do to keep changing direction, which obviously is really to do with how much fuel you're going to need and how efficient your engines are. So it goes back to that specific impulse as well. So you can work out, using your specific impulse, how much delta V your particular rocket has, using the Tsiolkovsky rocket equation.
Matt, I'm just asking, how are your engines these days? I mean, how...
As you know, Jamie, the Rover 75 is fitted with the classic BMW diesel engine. And it's a very good engine indeed.
It is lots of miles to the gallon.
Lots of miles to the gallon, very reliable. It's done 165,000 miles on the clock, and I still don't have to worry about the oil.
It's got no sign of slowing down, is it?
No, it's brilliant. And now I've done that, of course, you've cursed it. So if I break down the next time I drive my car, you're dead.
Oh, dear.
Oh, do you know what the
apologies in advance?
Do you know what
maybe Volvo will send you some merch now, Matt? Now you've given them a shout out.
No, it wasn't Volvo, though, was it? It's Rover who've gone bust.
Tits.
Thanks to the UK government not giving a monkeys about our industry. Anyway, Delta V's. You can add them up. You can just add them up linearly. That's what makes them so handy. And there's this thing called a pork chop plot.
Oh, here we go.
Yeah, which helps you display your kind of whole mission, and therefore the amount of delta V that you're going to require at any part of the mission, and so you know exactly how to fuel up your spacecraft.
Beautiful.
Yeah, so the Voyager programs obviously had very extensive pork plots with 10,000 potential routes that it could have taken through the solar system. And it allowed the JPL engineers to make sure that the major maneuvers and stuff didn't take place over Thanksgiving or Christmas. Okay. And to make sure that all the primary goals had been reached before the end of the fiscal year in 1981.
So was that just so that they could give the astronauts a nice Christmas dinner and they didn't have to worry about anything too complicated?
Yeah, exactly.
Beautiful.
Delta V.
There we go.
And I'm talking of something with huge delta V, possibly just enormous amounts of delta V this thing's had to have. I've been following Jonathan McDowell's coverage of the Parker Solar Probe. So we talked about Parker Solar Probe last week, and it did indeed, after a bit of a delay, fly up on a Delta Heavy, Delta 4 Heavy, so not a Delta 5. If only they made the Delta 5 and everyone called it the Delta V. But anyway, so it went up on a Delta 4 Heavy, and it, as we spoke about last week, and the one fact I forgot last week to mention was it's the only probe to be named after a living scientist.
Is that right?
How cool is that?
Oh, that's ace.
Yeah. So, but as we said last week, the hardest thing is to go towards the sun, 55 times harder than going to Mars in terms of the energy required. And here's some of the stats that Jonathan McDowell was tweeting about.
Sorry, I was just going to ask about Parker.
Well, we mentioned it last week. He's the scientist that proposed. We probably should have talked more about it, actually. But yeah, Parker is the scientist who kind of proposed a mechanism of how the solar corona is much, much hotter than the surface of the sun. And that's what the Parker Solar Probe's going to actually kind of eke out the details.
There we go.
But he's a legend.
Sorry, as you were, Matthew.
Yeah, so on the 12th of August at 7:30, the Parker Solar Probe actually took off. By 3:45, the Parker Solar Probe had passed the orbit of the moon. That's how fast it was going. And the second stage passed the orbit of the moon behind it at just 8 minutes past 5.
My Lord.
By 4:30 in the morning the next day, the solar probe had gone over 1 million kilometres from Earth.
It's just insane. Trying to wrap my head around that.
And later on that afternoon, it was 1.5 million kilometres from Earth. That thing is travelling at a fair lick.
That is a speedy Gonzales.
Yeah, and I thought he gave a really good explanation he says, the key thing to understand about this launch is it's in the opposite direction to Earth's motion. So normally, obviously, everyone's taking off to sort of get the spin of the Earth to help get a good orbit. But this is literally doing the opposite of that because it needs to shed some of the Earth's speed, basically. So it was a massive retro burn, like a spacecraft in Earth orbit does to re-enter and land. As the probe drops downhill in the solar gravity well, it picks up speed. Right now, at only 60% of Earth's speed at perihelion, it would be going 84 kilometres per second. But there's a Venus flyby before then. So how cool is that?
That is extra cool. Oh,
Yeah.
I love it.
Mm-hmm.
Good work, Parker.
One thing I thought was that keeps dropping in my inbox, and I thought I'd mention it because I think this is really, really cool. And David Baker mentioned this on our interview a couple of weeks ago. And
Yes.
but it was in a part of the interview where I was talking about various space technologies, so it probably didn't get the airing it deserved. But ESA are calling out for ideas for space transportation and business opportunities. So they've sent this, so they've sent this thing out, and you can actually enter. Anyone can enter. Basically, it's this. It's like this call for ideas as a first step towards identifying promising ideas within Europe for new privately funded, customer-orientated commercial space transportation. Businesses, big and small, research institutes, academia, and non-profit organisations are all invited to tell us about their ideas for new space transportation services. So,
Well, Matt, we need to write in.
no, absolutely. I'm going to be proposing my orbital ring idea. Because
Well, it's
why
about
bother?
time.
Why bother with launch services? Once you've built the orbital ring, you rule the world. That's it. Just put all your effort into that.
Done. Can I invest in you? Can I invest in your idea?
Yeah, you can definitely put some money in. Yeah, absolutely.
Sweet.
And the real cool thing about this is that once you've sent your idea in, all submissions will be assessed by the team of ESA experts.
I love that. Every one. Blimey.
Yeah. And they'll go through and say what's good and what's bad. And then they'll give you some kind of, how they're going to support the initial idea. And there's a whole bunch of things like the ESA Merit Stamp or Cachet. And then they'll offer coaching, mentoring, technical expertise. use of publicly operated test facilities. So there's a whole heap of things in here.
This isn't just them nicking your idea then. This is them wanting to help you develop it.
No, absolutely. This is them sort of saying, if you've got an amazing idea, we want to help you, really help you with this idea. I suppose in a way that NASA have helped someone like Elon Musk by giving him, by nurturing his idea and giving him money to help develop his reusable spacecraft. They want some organisation or some Uber entrepreneur to step forward and do a similar sort of thing in Europe. So, yeah, you've only got till the 14th of September to get your ideas in. And there's a really cool timeline about how that's going to happen.
God, that's amazing. I love that. Definitely going to put my thinking cap on.
Exactly. So get your ideas in. What I loved in there is that there's a technology readiness level definition, how advanced your technology is and how mature it is. And it's used by ESA and NASA. And there's 9 levels. So you go from 1, basic principles observed and reported, up to 9 with an actual system flight proven through successful mission operations.
Matt, mine's not very mature, I don't think.
No, well, the orbital ring is I think it's at technology readiness, maybe 2, technology concept and or application formulated. I think it's about there. Yeah,
but my maturity is that I want to make a euphemism about you saying orbital ring. That's how mature I am.
That's brilliant, Jamie. Why don't you write that one in? So just send it in.
That. Look out for that one.
Yeah. Right. Okay. Magnetic suppression of zonal flows.
Oh, finally. I've been waiting for this, Matt.
Do you know what? Did you watch the Horizon program about Juno and Jupiter?
I didn't.
Oh, it's still on the iPlayer, on the BBC iPlayer. So just watch it. It's brilliant. It's really, really good. Cool. But this kind of ties in because they've always wondered how deep. When you look at Jupiter, you've got the different coloured bands.
Yeah.
And they're basically the winds going around in different directions. And they're called zonal flows. Mm-hmm. They want to know, how deep do these zonal flows go? And zonal flows are in lots and lots of different rotating systems, including the Earth. I'm just trying to think of a really good one. Earth's polar.
I thought that's how one sounded. I thought you were just doing an impression of a zonal flow.
I was. So yeah, you got Earth's polar and subtropical jet streams, and all the atmospheres of Jupiter, Saturn, and Neptune all have those zonal flows. So yeah, there is a zonal flow in Uranus.
I've already made a ring gag.
Yeah, you have.
And you went there.
And
fair play to you, Matt.
But the great thing about those zonal flows is that the wind's all sort of going in different directions, is that there's no it doesn't allow for fluid to go from one place to another. So there's no exchange of heat or carbon. So there is, it gives these crazy effects in the weather and the colouring of Jupiter's atmosphere, etc., which you can see. So to understand this is really, really important. And so how deep do they go? So these zonal flows have an indirect effect on gravitational fields of Jupiter. So as Juno's been sort of flying around, it's been measuring these really, really tiny fluctuations in gravity. And so they've been able to piece together how deep these flows go. And it looks like the magnetic fields themselves actually disrupt the zonal flows and stop them going any deeper. So they know there's a connection now between the magnetic fields and the depth of these zonal flows, which is really, really important stuff.
God, that's nuts. I'm definitely going to watch that documentary.
Yeah, it's really good. It's just the fact that there's, liquid metallic hydrogen spinning around in the core of Jupiter, giving it this enormous magnetic and dangerous magnetic field that just stretches out way beyond the orbit of Saturn even. It's just ridiculous.
It's nuts, isn't it? It's a bit big.
Yeah. So, go and watch that Horizon program. It's absolutely brilliant. And by the way, Elon Musk has never met Azealia Banks.
Right. What I don't understand.
Have you not seen that Twitter storm?
No, what's kicking off?
Well, I can't be bothered to go into it. It's so ridiculous. But Musk's going out with Grimes.
Yes.
And Azealia Banks came over to kind of record an album.
Okay.
And then it never happened. So she's basically saying that Musk keeps basically just saying loads and loads of bad stuff about Elon Musk.
Oh, what a surprise. That's not like Azealia Banks.
But then
the sad thing is, Matt, is that she's genuinely super talented, but she's just mucking it all up. Very sad for her. I hope she can find some peace and just record good music.
So after like her tirade about everything about those two, Elon Musk says, "Well, I've just never met her."
Yeah, that's
just
it.
absolutely genius.
Brilliant.
So anyway, I thought it was worth, because he's just always tweeting and stuff, isn't he?
Yeah. I like that.
Is another thing that came out very similar to the ESA's call for ideas, was another paper, I think, which is from Lockheed, called the Small Launch Vehicles State of the Industry Survey.
Sounds like an interesting read.
It is interesting, Jamie. It is interesting.
I was being pedantic. I genuinely, I'm sure it is.
What is interesting is that there was a few companies in there that I'd heard of, but not really clocked. But I'll give you a little précis of the whole thing, basically.
Here we go.
And it kind of scares me a little bit, because it's really about how much this kind of very, very small satellite, up to 1 ton kind of thing, the small launch vehicles, basically, how much that's proliferating at the moment. So obviously loads and loads of people are building these small launchers to cater for this new market in small satellites. But it's happened before. In the 90s they did a similar sort of thing, and then that market sort of shriveled up, and it's a sort of chicken and egg situation, where it's like you want to build these small launchers so that you can launch constellations, but then constellations are only financially viable if you fly them a lot at a low cost, which just they could never quite square that circle, or circle the square, or get the peg in, whatever the phrase might be. But the same thing's happening again now. Everyone's sort of piling in to small launch vehicles. Now, guess who's at number 3 after America and China in development of launch vehicles, small launch vehicles?
UK?
The UK, with 20 small launch vehicles in the USA, 6 in China, 4 in the UK, if you include their partnership with the Ukraine for one of them. And then after that, you've got Spain on 3, and then just a whole bunch, Argentina, Australia, Brazil, Europe, and India. Now, the Europe one is actually the space plane, which is an interview we had the Space Rider, which is an interview we had quite a while back, and that's considered,
that's right.
That's considered a small launcher, because it drops down the capability of Vega. And it'll fly on top of Vega C. So that's going to be really exciting when that starts flying. But the great thing about that, of course, is it can come down, land on a runway, and can get your experiments off really, really quickly. But there's absolutely loads of these launch vehicles, and it's obvious that everyone's trying to go for this prize, but most of these companies are going to fail.
Oh.
So it's going to be carnage. Well, because there just isn't, one of these companies will somehow bring the cost down so that everyone will want to use them, and there'll be say 2 or 3. But we're talking, we've got 30 odd companies in competition now, which is crazy. And there's some so that the UK ones are Orbital 500R, Orbital Access, and they fly up on a carrier aircraft, a DC-10. You've got Prometheus 1 by Space LS, which basically uses old technology of the hydrogen peroxide kerosene engines. The Skyroarer XL, which is the half Ukrainian, half UK team.
Nice.
And the Space Rider is the European one. So there's a whole heap of these things, and of course Orbex as well.
My money's on Prometheus, Matt.
Is it? Yeah, it does. Yeah, it is. It's a good one. It's a good one to have your money on. My money's on Orbex, in actual fact. So yeah.
Okay.
But all of these things, they sort of, when you look at the price tag, they sort of fall somewhere between $10,000 per kilogram into space. That's Firefly, the recently resurrected Firefly, and they go all the way up to like very, very expensive, sort of $60,000 per kilogram. But they most of them sort of sit in that 20,000 $20,000 to $30,000 per kilogram sort of range. But just put that into perspective, Falcon 9 only costs $2,700 per kilogram. So this is the thing I don't understand is, do you really need to have your own dedicated launch vehicle? Or might it be better for virtually everyone just to stick all their stuff on these larger rockets like Falcon 9? I don't know. So it's going to be
a tricky one, isn't it?
It's going to be really, really interesting how this all pans out. But what I do know is that the UK are really stepping into this market big time with the Cornwall and Scotland announcement. So that's going to be really interesting how it pans out, because it might pan out really, really well, and in which case the UK is very much at the forefront of all that. And of course, we make a lot of those small satellites as well.
Long may that continue. Exciting stuff.
Yeah. So there's a couple of launches coming up. On August the 21st, there is a Vega rocket launch, and again I saw some of the hardware for that, and that's ADM Aeolus, which is a weather satellite, really exciting one. That is like a technological marvel. It was supposed to fly sort of round about 2007 or something like that, but it's been so hard to develop. It's going up now, and I'm actually going over to Germany, Darmstadt, to ESOC to watch that from the control room there.
That is going to be another ace journey.
It is going to be an ace journey. I'm going to interview some really, really fantastic people about that launch, so I'm really excited about that. And on August 24th, we will see Falcon 9 taking up Telstar 18.
Beautiful.
Which leaves us again with no interview this week. We're going to be piling up some interviews over the next few days, though. We've got them stacked up. We've got a really exciting guest for next week, and also all those brilliant guests the following week from the Vega launch.
Exactly.
The Interplanetary Podcast is alive!
So, just one last thing.
Go on.
Space fact, and I absolutely love this, Jamie. It's so cool. It's related to Delta V, and it's something that the mighty Hermann Oberth, the Austro-Hungarian-born German physicist,
Big Herm.
Well, he is regarded as the founder of modern rocketry.
Really?
Yeah.
Oh, I must be second.
Well, we're not talking super postmodern rocketry.
Yeah.
Because you're definitely...
I'm like the sun.
Yeah, you're definitely a postmodern rocketry man.
PMM.
Yeah. Jamie Franklin, postmodern rocketry.
That's what they call me.
Oh, yes, you could send that in as your idea. Your business venture, Jamie Franklin, postmodernrocketry.com.
Well, it's got an orbital ring to it.
Hey!
Do you like that, Matt? Do you like that?
That was really good.
Really good.
Get this.
Yeah?
So, in astronautics, a powered flyby or Orbeth maneuver is a maneuver in which a spacecraft falls into the gravity well of a body, like a planet or whatever, and then accelerates just at the point where its fall is reaching its maximum speed. And the amazing thing about that is the resulting maneuver is lots more efficient in gaining kinetic energy than applying that same thrust or impulse outside of the gravity well. So let me just explain that just really quickly, is if you've got something like the Parker Solar Probe,
right,
and what it wants to do is speed up. Say if it's in a massive elliptical orbit around the sun, and obviously the fastest point is when it comes in and gets to periapsis, so where it gets to its nearest point of that elliptical orbit. And as it gets there, it's going to be going its fastest, right? And at that point, if it uses its thrusters to help accelerate, then it will gain the best advantage at that point. And it's just something that Orbith noticed from the maths, that is the best time to use your use your thrusters. And in fact,
that's going to save a lot of fuel, isn't it?
Yeah, exactly. Well, it's really, really important for saving fuel. And get this, in some cases, it's even worth using some fuel up to slow the spacecraft into a gravity well to take advantage of the Orbith effect. So sometimes it's actually worth like burning a bit of fuel just so that you can use it in this at this fast point of the gravity well orbit.
Cool, I love that.
Yeah,
that's ace.
It is ace. It's how brilliant how maths works and how you can spot these things. So I think he first described that effect in 1927.
Is it Oberth or Oberth, Matt?
I don't know. I'm going to go with Oberth.
Matt, should we get Oberth tattoos?
I'm getting an Oberth tattoo for sure. He's a bit of a nutter. I think he believes in UFOs and stuff like that. Because when you see Oberth quotes, they're all over the shop.
I think we should do a little feature on him.
Yeah, well, let's do it. Okay, next week we'll have a Herman Oberth feature. How about that?
I'd like that.
He can be our legend of the week, can't he?
Big Herm. Love it.
So, Jamie.
Yeah?
You've been listening to the Interplanetary Podcast. Putting the ace back into space.
Hey, I just want to say thank you to everyone who's going onto iTunes and leaving us a lovely 5-star review. Listen, these reviews, they may not seem like much, but it will take you 2 minutes, and it genuinely is a real great tool for allowing others to find our podcast and allowing this podcast to grow. So along with our patrons, God bless you, and the people who leave reviews, God bless you. And the comments that we get on Twitter, on Instagram, that excite us and fuel the shows. Again, thanks so much. So keep all the feedback coming, guys. It's what powers us, Matt, isn't it? It's what powers our kinetic energy.
I can't even begin to imagine. Well, it is definitely what keeps us going.
It keeps our zonal flows flowing.
And anything, the best, of course, is the people that wander over to Patreon.
I mean, what can you say about them?
And we've had even more patrons this month, and I'm so excited. Can't wait to read their names out on our first week of the month episode, because these people are legendary.
As we know, Matt, from last week, they get special sections that no one else hears.
Yeah,
just saying.
The special monthly news, which I think one person described as unbelievable production value.
Oh wow.
Yeah.
Too kind. So Matt, I'm off to eat a pork chop plot. What are you up to?
I'm off to finish my Tesco meal deal Hosin duck wrap.
Wow.
Yeah.
Enjoy it. Thank you, listeners. Take care of yourselves and each other.
Bye, Spodcats.
Bye.
Bye.